Okay, for this question, we're answering what an iterated integral is. And so there is the actual definition is linked below the question on OneClass. But if you're given this and you just genuinely did not know the answer, we can just look at the words in it, quite literally. Iterated reminds you of the word iterations. And we've seen this word in math a lot. Iterations means you're repeating whatever it is you did. And so if we're doing iterations of derivatives, that means you're repeating taking the derivative multiple times. So you take the derivative the first time, and then you take the second derivative, and then the third derivative. And let's say you decided to stop here, you would say the third iteration of the derivative. And so now that we're talking about integrals, iteration reminds you of doing something multiple times, right? So now that we're talking about integrals, that means that we're going to be integrating multiple times, is what the question basically tells you straight up. And so in integrals, what is going to cause us to integrate multiple times would be the presence of multiple variables in whatever our function is. So these are called multivariable functions, and they can spit out scalar values or other vectors. And so if we have f of xy or f of xyz, you could have as many variables as you'd like, or as given in the question. So let's take the example of f of xy. What integrating multiple times would look like would be integrating over x, and then integrating over y, fx, y, and let's say we're doing dy, dx. And so this would be a double integral. And so this gives you a more intuitive feel, I guess, on what the words actually mean before you get into the definitions. The definition online is it's an integral formed upon integrating a function of more than one variable in a way that each of the integrals considers some of the variables as given constraints. And so what I've described here basically. And so first we'd integrate over y, whatever the function is, and as we're integrating over y, we're going to treat the x values inside of this function as though they're just constants, because we currently don't care about them because we're integrating over y. And then after we get the answer for the integral of f of xy, we're going to integrate over x next. And since we've already taken the integral with respect to y, there'd be no more y terms left, only x terms or constants, and then you get your final answer. And so a good example of this would be, let's say we have the function f of xy is equal to xy as an example, right? And then we'd like to integrate last as x goes from, so x is equal to 1 to x is equal to 3. But firstly, we'll be integrating from y is equal to 2 to y is equal to 6, okay? And so since we have xy, dx, dy, right? And so first, you're going to treat the x term as a constant. So if it was a constant, we know that the integral of a into f of x times dx, we can pull out that constant. And so that's exactly what we're going to do here. And we're going to pull it out. So it becomes the integral from x is equal to 1 to x is equal to 3 of x multiplied by the integral from y is equal to 2 to y is equal to 6 of y dy dx. My apologies, you're supposed to say dy first because it's the first integral that you're taking, and then the dx. Okay, and so we know that the integral of y, just using exponent rules, is going to be y squared over 2. and we're taking it from y is equal to 2 to y is equal to 6. This is still within integration bounds, but let's first evaluate this. So we come from x is equal to 1 to 3 of 6 squared over 2 minus 2 squared over 2 dx. So 1 to 3 of 36 over 2, which is 18, minus 2 squared over 2, so 4 over 2, and that is going to give me 2 over dx. So 1, 2, 3 of, don't forget the x term that was here, my apologies, of x into 18 minus 2, which is going to be 16. And so now we're going to figure out this integral next. So it becomes from 1 to 3, we're going to pull out the 16 because it's just a constant. So 16, 1 to 3 of x dx, which will become 16 into x squared over 2. 1, 2, 3. So 16 into 3 squared, so 9 over 2 minus 1 squared, 1 over 2. So 16 into 8 over 2. And this will become 8 by 8. And so that will become, that will become 8 by 8, which should give us 64. And that will be your final answer for the integral from 1 to 3, 2 to 6 of x, y, dy, dx. So this is just an example of how to do it.